Look up at the night sky. What do you see? A smattering of stars, perhaps a planet or two. Now imagine you could zoom out, way out, past all the stars you can see. You would find yourself looking at our galaxy, the Milky Way. It's a vast, swirling collection of stars, gas, dust, and planets. Where are we in all of this? We call Earth home, a planet orbiting a star we call the Sun. But our Sun isn't unique, it's just one of billions within the Milky Way. Think of it like this. You live in a house on a street, in a city. Our cosmic address is similar. Earth is our house, the solar system is our street, and the Milky Way is our vast, sprawling city of stars. But instead of houses, our galaxy is filled with stars, nebulae, and mysteries yet to be discovered. It's easy to feel small in the face of such immensity, but there's also a sense of awe. We are part of something much bigger than ourselves. We are connected to every star, every planet, every atom of gas and dust in this vast cosmic tapestry. And as we explore the Milky Way, we learn more about our place in the universe and the incredible forces that shape our existence. The Milky Way is a barred spiral galaxy. Imagine a giant disk like a frisbee with a bulge in the center. That's our galaxy. Spiral arms, like graceful streams of stars and gas, wind out from the central bulge. Our Sun sits on one of these arms, about 2/3 of the way out from the center. If you could see the Milky Way from above, it would look like a giant glowing pinwheel, but we see it edge on from Earth, so it appears as a faint band of light across the night sky. This band is actually the combined light of billions of stars, so distant that they blur together into a milky stream. The Milky Way is vast. It spans about 100,000 light-years across. To put that in perspective, light from one end of our galaxy takes 100,000 years to reach the other end. Our galaxy is also home to hundreds of billions of stars, along with countless planets, moons, and clouds of gas and dust. At the very heart of the Milky Way lurks a monster, a supermassive black hole. Don't worry, we're nowhere near it. This black hole is about 26,000 light-years away from us, but its gravity is so strong that it holds our entire galaxy together. Imagine a giant whirlpool sucking everything around it into its center. That's kind of what a black hole is like. Its gravity is so intense that nothing, not even light, can escape its pull. As material falls into the black hole, it heats up and emits intense radiation, making the galactic center a bright and energetic place. While black holes sound scary, they're actually essential to the formation and evolution of galaxies. They act as cosmic anchors, holding everything together and influencing the movement of stars and gas over vast distances. So even though we can't see our galaxy's supermassive black hole directly, we know it's there, playing a crucial role in the cosmic dance of the Milky Way. Stars, stars everywhere. The Milky Way is teeming with them, each with its own story to tell. There are bright, hot stars burning blue-white, and cooler, dimmer stars glowing red. Some stars are giants, hundreds of times larger than our Sun, while others are tiny dwarfs barely bigger than Jupiter. Stars are giant balls of hot gas, mostly hydrogen and helium. They shine by nuclear fusion, a process where hydrogen atoms fuse together to form helium, releasing tremendous energy in the process. This energy is what makes stars hot and bright. The life cycle of a star is a fascinating story of birth, evolution, and eventual death. Stars form from collapsing clouds of gas and dust, ignite in nuclear fusion, shine for millions or billions of years, and then eventually die, sometimes in spectacular explosions called supernovae. These stellar explosions scatter elements into space, seeding the galaxy with the ingredients for new stars and planets. Section 5, Cosmic Nurseries, Star Clusters and Nebulae. Stars aren't born in isolation. They form in vast clouds of gas and dust called nebulae, which act as cosmic nurseries for newborn stars. These nebulae are some of the most beautiful and awe-inspiring objects in the universe, often glowing with vibrant colors from the light of nearby stars. Within these nebulae, gravity pulls together clumps of gas and dust, causing them to collapse and heat up. Eventually, the core of these collapsing clumps reaches temperatures and pressures high enough to ignite nuclear fusion, and a star is born. Often stars form in groups called star clusters. These clusters can contain hundreds, thousands, or even millions of stars, all bound together by gravity. Over time, stars in a cluster will gradually drift apart, but their shared origins are evident in their similar ages and compositions. Section 6, Beyond our Sun. The search for exoplanets. For a long time we wondered, are there other planets out there orbiting distant stars? Now we know the answer is a resounding yes. In recent decades, astronomers have discovered thousands of planets beyond our solar system called exoplanets. These exoplanets come in all shapes and sizes, from gas giants larger than Jupiter to rocky worlds like Earth. Some orbit their stars closely, completing an orbit in just a few days, while others take hundreds or thousands of years to circle their stars. The discovery of exoplanets has ignited our imaginations. Could some of these distant worlds harbor life? Scientists are actively searching for signs of life on exoplanets, looking for telltale signatures in their atmospheres or other clues that might indicate the presence of living organisms. The search for life beyond Earth is one of the most profound quests in science, and the discovery of even the simplest life forms on another planet would revolutionize our understanding of our place in the universe. Section 7. The Unseen Universe. Dark Matter and Dark Energy. Here's a cosmic mystery. It turns out that most of the universe isn't made of the stuff we're familiar with. In fact, the vast majority of the universe is composed of something called dark matter and dark energy, mysterious substances that we can't see or interact with directly. We know dark matter exists because of its gravitational effects on visible matter. Galaxies rotate faster than they should based on the visible matter alone, suggesting that there's some invisible dark matter holding them together. Dark energy is even more mysterious. It's a force that's causing the expansion of the universe to accelerate. Imagine baking a loaf of raisin bread and noticing that the raisins are moving farther apart at an ever-increasing rate. That's essentially what dark energy is doing to the universe. While we don't know what dark matter and dark energy are made of, their discovery has revolutionized our understanding of the universe. It turns out that the familiar matter we see around us is just a tiny fraction of what's really out there. The vast majority of the universe remains shrouded in mystery, a tantalizing reminder of how much we still have to learn about the cosmos. Section 8. Galactic Ballet, a dance through time. Galaxies aren't static islands in space, they're dynamic systems, constantly evolving and interacting with their surroundings. The Milky Way is no exception. It's on a collision course with our nearest galactic neighbor, the Andromeda Galaxy. Don't worry, this galactic collision won't happen for another few billion years. But when it does, it will be a spectacular event. The two galaxies will pass through each other, their stars and gas clouds interacting in a complex gravitational dance. Over time, the two galaxies will merge, forming a single, larger galaxy. Such galactic mergers are common throughout the universe, and they play a key role in the growth and evolution of galaxies over billions of years. So, even though the Milky Way seems like a permanent fixture in the night sky, it's just one stage in a much longer cosmic story. Section 9. The Milky Way's future, a glimpse ahead. What does the future hold for our galaxy? In about 4 billion years, our Milky Way will collide with the Andromeda Galaxy. This collision will be a slow and graceful dance, lasting for millions of years. The two galaxies will distort each other's shapes, their spiral arms twisting and turning as they intertwine. Eventually, the Milky Way and Andromeda will merge into a single giant elliptical galaxy. This new galaxy will be a cosmic melting pot, its stars a blend of the two original galaxies. Our Sun, nearing the end of its life, will likely be flung out into a new region of this merged galaxy. Even though our Sun's time is limited, the stars that form from its scattered remains will continue to shine for billions of years to come. The cosmic dance will go on, with new stars being born, old stars dying, and galaxies continuing to evolve and interact in the vast expanse of the universe. Section 10. Our Cosmic Connection, a Universe Intertwined. As we explore the Milky Way, we discover a profound truth. Everything in the universe is connected. The atoms in our bodies were forged in the hearts of stars that exploded billions of years ago. The elements that make up our planet, our bodies, and everything around us were all created in the fiery furnaces of long-dead stars. We are, quite literally, stardust, and we are part of a vast cosmic web, connected to every star, every planet, and every galaxy in the universe. The energy and matter that make up our bodies have been recycled over billions of years, flowing from stars to planets to nebulae and back again. This cosmic connection is a humbling thought. It reminds us that we are not isolated beings but integral parts of a much larger cosmic story. As we continue to explore the Milky Way and beyond, we gain a deeper appreciation for the interconnectedness of all things and our place in the grand scheme of the universe.